this second session of electrostatics. In the last video, we deal with the concept, the beginning concept of electrostatics, and this is the second part now. We're going to be dealing with field concept and go into calculations. So now, we're starting with gravitational constants. So, we know gravitational constant as so, and there is another way to get gravitational constant apart from this. We know gravitational constant to be 9 times 10 raised to the power 9. So, but we can get it in another way. That is when it is involving the permittivity. We can get it as 4 by units. So, and what is units? Units is the permittivity of free space. Permittivity of free, we either say free space or vacuum. So, permittivity of free space, we have that as 8.8 by times 10 raised to the power minus 2 5 by 5. So that is permittivity of vacuum. So now if we start this here and you calculate it on calculator, you will still get 9 times 10. You still get your K as 9 times 10 raised to the power 9. 18 meters per second. So you still have this value. So this is going to be useful here when we are solving this question. So what is permittivity of medium? When you have permittivity of medium, the formula is permittivity of medium is equals to E naught multiplied by ER. Now what is E naught? What is ER? E naught is the permittivity of vacuum. I define that here. Now ER is the relative permittivity, or you can call it dielectric constant. So say ER is relative permittivity. You see dielectric constant. So now under relative permittivity, we have materials. It can involve air, it can involve paper, it can involve glass, it can even involve paraffin. So it's depending on what they are giving you in the question. So I will just list them out. So here I will see for air, the material and the constant. Can either say is K or AR. So for air it is 1.0, for paper it is 2.0, for glass it is 8.0, for paraffin it is 2.2. So that is the energy constant for each of these materials. So now without wasting much of our time, let's go through the questions. We have 2 point charges plus 4 microcoulomb and minus 6 microcoulomb that are placed at this distance. So and we are asked to calculate the force between them in air. You can see that this is where the relative permittivity comes in here. So then after that we are going to check the space between them. If it is filled with the dielectric material of relative permittivity 5. So we are going to calculate another force again. We are still making use of the Coulomb's law, but we are going to be inserting the relative permittivity into them according to what we will do. So lastly, we are going to check the factor that the force G. So and I told us in the first session that if your charges are opposite, what kind of force will happen? That will be attractive force, because when the positive charges is releasing charges, the negative charges will not accept it. So now calculating the force here, using the formula F is equals to KQ1 Q2 over R squared. But now we are having A. This having the relative permittivity of 1.0. So we have to include it in the formula. So that means we are representing this K with this here. We are representing this K. So we bring this here. The reason why is that we are going to insert the permittivity that was asked, permittivity that was given in the question. So now, right here we'll be having F is equals to 1 over KQ 1 over 4 pi E naught, then multiplied by Q1 Q2 over R squared. And then we'll be having 1 over 4 pi What's our E naught going to be? We already know our ER to this, and we know that E naught times ER. So that's going to be 1 and inserting 1. So now we are calculating the force and we are using this formula. Remember, this is 1 over 4 pi E naught. Remember that it's including a relative permittivity of A, which is 1.0. It's going to be included. So now we multiply that with the permittivity over PA. So we multiply by that we're going to be having 8.85 times 10 raised to the power minus 2. Then now we now take the two charges. We have plus 4 microcoulomb and minus 6 microcoulomb. Remember, microcoulomb is times 10 raised to the power minus 6. So we represent those to you. So we're going to multiply by 4 times 10 raised to the power minus 6 and minus 6 times 10 raised to the power minus 6 over r squared. Now, our r is the distance, which is 0.3. So we are having 0.3 squared. Now, your basic permittivity is multiplied by 1. So since it's multiplied by 1, it will still give you the same value as your key, which is 9 raised to the power 9. Do you understand? So now, to calculate that force, calculating the whole of this, we're going to be having 2.4 units. So our first day is 2.4 units. That's for the first question. We've calculated the force between them and them. Remember, we put the relative permittivity here. So you have A naught and the permittivity multiplied by that. The combination of all the formulas, which is Q1, Q2, but also you get your force. Now the second question says, if the space between them is filled with dielectric material. Now we are dealing with another dielectric material, which is 5. This one is not specific, we are given. So now calculate the force. Now you have to take over the formula that says that the force of the medium is going to be the force of A over the permittivity. Now, the force of medium is going to be the force of A. And what is the force of A? That is 2.4 over the permittivity, which is 5A equation. So the force of the medium is going to be the force of the A over the relative permittivity. Now, how do we get to that? Remember, the formula of the force is Q1, Q2 over r squared. Now, this K, you also know it as 1 over 4 pi E naught ER, right? Multiplied by Q1, Q2 over r squared. Now, you can see that this here is our key. Is our key. So, if we represent this back as key, we'll be having F is equals to KQ1, Q2 over r squared, and multiplied by 1 over this. So I'm know that the whole of this is our force. So you can see force over the relative permittivity, which is what we did here. So to calculate this on our calculator, we're going to be having 0.48. That is for when the relative permittivity 5 is included. So that's how we drop our force. Now lastly, by what factor does the force change? That is when we relate two forces together. So it's going to be the ratio of the first force that we put over the second force. So the factor is going to be force of A over the force of the relative permittivity. The second one. So that's going to be 2.4 over 0.48. So and that's 5. That means the force decreased 5 times. As the force decreased 5 times. So that's the final answer for this. Now, the second question is find the force at the center between the charge B. We have charge 1, charge 2, this and charge 3. Then this force acting backwards, and this force acting forward. You have to look for the force at the center. Okay. So to look up the force, we are going to be taking the two charges. We have to get F1 and F2 to get the force. Here we are doing this. F is equals to F2 minus F1, right? So we need F2, we also need F1. How do we go about that? To get our F1, we are using these two charges in common. Then to get our F2, we are using these two charges in common. So now we are still using the same Coulomb law. So I will say F1 equals to KQ1 Q2 over R squared. Then I will say for F2, I will say Q2 Q3 over R squared. We're getting up. So now can insert. Remember, this is in nanocoulombs. Now nano is times 10 times 10 times 10 is to the power minus 9. That's nano. So when you are dealing with your charges, you have to be very, very conscious of the unit. So you have K, which is 9 times 10 is to the power 9, and multiplied by the Q1, which is 2 times 10 is to the power minus 9. We have it minus 4 times 10 is to the power minus 9, and equals all over the R square. The R here is 4, so we have 4 square. So now let me just say, calculating that on our calculator, we have 4.45 nanocoulombs. That is 4.5 times 10 is to the power 9 minus 9 actually. That would be 4.5 nanocoulombs. Yes, so now for the second force, we are using the same formula. So we have F2 is equal to 9 times 10 is to the power minus 9 and multiplied by what's our Q2? It's minus 4 times 10 is to the power 9. Your Q2 is going to be 8. So that equals 10 to the power minus 9. Where you have R squared, which is 2 meter. So you have 2 squared. So F2, calculating that, we are going to be having 68 nanometers. We are going to be having 72 nanometers. 7.2 times 10 is to the power minus 8. And Newton, this is Newton, not nano. We are calculating force, not charge. So it's supposed to be Newton. Newton. So this, you can bring this point here and make it turn to minus 9. This is going to be nano. So I can say 7.2 times 10. 72 times 10 is to the power minus 9, which is still the same thing as 72 nanonewton. So now that we have our F1 and F2, we have calculated our F. So just see F according to this side. F2 is 72 nanonewton minus 4.5 nanonewton. So first is going to be, so now the answer is 67.5, approximately that's 68 nanonewton. So and that is the answer for the first at the center, which is our F. Thank you for watching. We are still going to be doing more sessions on this. So do well to like, subscribe, share. Thank you.